All right, today we are cracking open the cybersecurity playbook. We're going to decode the exact security techniques you'll find in the CompTIA Security Plus certification. The goal here is simple, to give you a real, practical understanding of how digital defenses are built layer by powerful layer. Let's jump right in.
So why are we zooming in on this specific stuff? Well, look at this number. A massive 28% of the SYO-701 exam, that's one of the key certifications that gets you hired, is all about security operations and techniques. So, getting a handle on this isn't just about passing a test. It is about understanding the absolute core of how we defend our digital world today.
You've heard all the buzzwords, right? Firewalls, antivirus, endpoint detection, the list goes on. But here's the thing. Having a big pile of security tools isn't the same as having a real security strategy. So the big question is, how do you get all those different pieces to stop acting like individuals and start working together as one single unified defense?
And the answer is a powerful philosophy called defense in depth. Now, the best way to think about this is to picture a medieval castle. A castle isn't just one giant wall, is it? No way. It's got a moat, then an outer wall, then an inner wall, and archers and guards at every single gate. Each layer is there to slow an attacker down, to make their life difficult, and ultimately to stop them cold. That is exactly what we're going to do in our digital world. We're applying that same layered thinking with defense in depth.
Okay, layer one. This is where it all begins. It starts at the absolute core of our systems. Before we even think about the network or firewalls, we have to make sure every single device, every server, every application is as tough and resilient as it can possibly be. It's all about making each asset a hardened target.
And the starting point for that is something called a secure baseline. Honestly, just think of it as the master blueprint for security. Before a new laptop ever gets handed to an employee or a new server is spun up in the cloud, it gets built and configured according to this strict, secure blueprint. This makes sure there's a minimum standardized level of security across the board. It eliminates those weak links right from the very start.
And when we talk about what we need to harden, well, the scope is huge. This isn't just about our laptops and servers anymore. We're talking about everything. The smartphone in your pocket, the cloud servers running our apps, the routers and switches to connect everything, even industrial systems running a factory, or the millions of IoT devices out there. Every single one of these is a potential doorway for an attacker, and each one needs to have its attack surface shrunk down as much as possible.
Okay, so our devices are hardened, they're tough. But what about the software that's actually running on them? Application security can't be this thing you just bolt on at the very end and hope for the best. It has to be baked in, right, from day one of the development process. It's got to be part of its DNA.
One of the most critical techniques here is input validation. Think of it like a super strict bouncer at the front door of your nightclub, your application. It checks the ID of every single piece of data trying to get inside. And if that data looks shady, say it's a piece of malicious code pretending to be a username, it gets thrown out. This one simple check is our front line against some really devastating attacks, like SQL injection, where a hacker tries to sneak database commands right through a web form.
Now, to actually find these flaws in our code, we've got two main approaches. First, you have static analysis, or SAST. I like to call this one the architect. It literally reviews the application's blueprints, the source code itself, looking for structural flaws before the app is even built and running. Then on the other side, you've got dynamic analysis, or DAST. This is the crash tester. It takes the finished, running application and just tries to break it. It smashes it with tons of random, malformed data, a technique we call fuzzing, just to see what sticks and where the weak points are.
All right, so our core assets are hardened. Our apps are more secure. Now we can move outward to our second layer of defense, guarding the gates. This is all about controlling the traffic flowing into and out of our network. Just like the guards at the castle gate deciding who gets in and who stays out.
And a key piece of tech here is Network Access Control, or NAC. This is your network's digital bouncer, plain and simple. When any device, a laptop, a phone, whatever, tries to connect, NAC stops it at the door and gives it a quick health check. Is its antivirus up to date? Does it have the latest security patches installed? If it passes the inspection, great, come on in. If it fails, it gets sent to a special quarantine area until it can get patched up and healthy. This makes sure that only clean, compliant devices can get anywhere near your important data.
Now let's talk about one of the biggest gates of all, email. We secure it with a trio of protocols that are designed to work together. First up is SPF. Think of this as the mailman's ID check.
It just confirms that the email is coming from a server that's actually allowed to send mail for that company. Second, you have DKIM. This is like a digital wax seal on a letter. It adds a signature that proves the message wasn't opened and tampered with along the way. And finally, you have DMARC, who is the policy enforcer. It's the boss that tells the receiving email server exactly what to do if an email fails either the ID check or the seal integrity. Just reject it or toss it in the junk folder.
And that brings us to our third and final layer. So we've hardened our assets, we've guarded our gates, but we have to assume that a really determined attacker might, just might, still find a way through. This layer is our enterprise eye. This is the watchman on the castle walls, constantly scanning the horizon, looking for any sign of trouble across the entire kingdom.
A perfect example of this is File Integrity Monitoring, or FIM. What this does is it takes a snapshot, like a photograph, of all your critical system files when they're in a known good state. Then it just watches them, constantly. And the second anything changes, a file gets modified, deleted, or a new suspicious one is added, bam, an alarm goes off. It is an absolutely essential early warning system.
Now, at the most advanced level of this monitoring, we have two key technologies. There's Endpoint Detection and Response, or EDR. The easiest way to remember this one, it watches the devices. It logs pretty much everything happening on all the laptops and servers, hunting for the subtle footprints of a sophisticated attack. And then you have User Behavior Analytics, or UBA. This one watches the people. It uses machine learning to figure out what normal looks like for every single user. So if, say, an accountant who only works 9 to 5 suddenly tries to access top-secret engineering files at 3 in the morning, UBA is going to flag that as a massive red flag.
So, you see how each layer builds on the last one? Hardening our assets in layer 1, that's our foundational kind of passive defense. Then, filtering traffic at the gates in layer 2, that gives us a medium level of control. But it's only when we add this third layer, this active, enterprise-wide monitoring, that we gain a truly high-level capability to actually detect and respond to the kinds of advanced threats we're facing today.
So, let's put it all together. Let's zoom out and look at the big picture. What we've just walked through isn't just a random collection of security tools. It's a complete blueprint, a coherent strategy for building a truly robust digital defense. And it's all built on that powerful core principle of defense in depth.
It's a really simple but incredibly powerful model. First, we secure the core, making every individual piece as tough as possible. Second, we guard the gates, controlling who and what gets onto our network. And third, we deploy the enterprise eye, actively hunting for any threats that might have slipped past our first 2 layers of defense.
Now, each of these layers we talked about was really developed in response to threats getting smarter and more sophisticated. This 3-layer model is pretty much the gold standard for today, but the threat landscape never, ever stands still. Which leaves us with one final and I think pretty crucial question to think about. As the attackers keep innovating, as they start using AI to craft newer, more devious attacks, what will the 4th layer of defense need to be?